Good afternoon. Welcome to our fifth episode of Azure Community Interest User Group. My name is Nicholas. I'm with one of the co-hosts. I'm with Kevin Green.
Hey folks, welcome aboard for another episode. Got some fantastic speakers lined up for us tonight. And before we kick off and introduce them, I think, Nick, you've got some housekeeping.
Yeah, so we got some housekeeping stuff that I want to show everyone. So this is our welcome to our presentation. So this group is founded by Nicholas. My name is Nicholas and Kevin Green. To stay up to date, you can either scan that barcode and follow us on LinkedIn, Twitter, YouTube, and Facebook. And you can see past recording if you want. So code of conduct. So all members of this group should follow this code of conduct. For example, you need to be friendly and welcoming to everyone, and to be patient. So be patient, everyone, because everyone have their own time. Be thoughtful, be respectful and inclusive of everyone, of your decision, because treat everyone how you should be treated, and be open and curious. So ask questions to understand and not to criticize anyone. So today's agenda would be like container apps and some blogging. So the first session in a few minutes would be Simon Lee. So he's an Azure Support Engineer at Intercept, and he will be speaking about how to get started with static web apps and blogging.
And second speaker of the night, we'll have Johnny Hooyberghs, and Johnny's a Microsoft MVP in developer technologies. And Johnny's session is titled Deploy Your Cloud Native .NET 8 Apps to Azure Container Apps. So I'm really looking forward to looking at the two presentations from both Simon and Johnny. As usual, I'm always learning. Every time we do one of these episodes, Nick, I'm always learning some new content for myself.
Yeah. So we will be closing approximately 9:40 p.m. And then the next episode will be like the Christmas episode, doing two. So the first one will be doing a session on developing security for Defender for Cloud by Dylan White. He's a senior Microsoft security architect at CDL. As well, the second speaker will be doing a session on crafting a subject-centric sidekick with Azure Container Service and OpenAI by Rod Trent at Microsoft. So stay tuned on that episode on the 11th of next month. So just have fun and ask questions, make it interactive, so we learn from each other. So let me get our first session on stuff.
Hello.
Yeah, so Simon will start his first session. He will just get started with his static web apps and blogging.
Sure. Cheers. Thanks, Nicholas and Kevin. I was going to say, we're going to bring on this troublemaker to give me some support. Firstly, thank you, Wesley, for giving me a hand with this. Yes, I'm waiting.
Anytime, buddy.
Start. So today I'm going to be giving a short slide deck on getting started with static web apps. This is a really interesting topic for me personally, because at the end of the year, I am deprecating my WordPress website, which I've had for the past 8 or 9 years now, and moving over to a static web app, which is really cool. So this has been part of the learning that I've done over the last sort of 3 or 4 months with playing around and asking Wesley and Richard and Carl for some help and support on this. So firstly, some background. Who am I? I'm Simon. You probably know me on Twitter. I drink far too much coffee, have a really good love of Formula One and Red Bull. So my background is that I started out in the education sector in doing IT in primary schools, then progressed into doing some small to medium business stuff, then did a stint at CDW doing some configuration work for them, then doing some software deployment stuff for a college down in the Midlands in the UK, and then met Wesley and the team at Intercept, which is where I am now, and doing all things Azure. And so, if you want to follow me, if you're not already following me on Twitter, I know it's called X, but for, nostalgic reasons, it's always going to be Twitter regardless. So you can, follow me on Twitter. If you want to add me on LinkedIn, it's there. If you want to go stalk my GitHub profile and see what I'm building and deploying. And then if you want to see the old site, which is going to stay there after January, the new site is still in development and I'm still tweaking the theme. It's the hardest bit, isn't it, Wesley? Trying to find a theme that looks just right with all the right colors in and stuff. So it's almost there and almost ready to go live.
Mate, I'm very happy you're doing it.
I know the amount of stick that you guys have given me for saying that you're working with Azure now. You need to get an Azure Cloud friendly solution which works, and I've put it off for long enough. So
it's
it's time
peer pressure in a positive way. And
definitely.
I have to say though about the coffee, I witnessed it this morning. Stand up. So I lead the stand-ups currently for one of the teams, and to be fair, Simon is my trusty fall-in when I cannot make it. But this morning it was asking Simon questions, and I think we ended with, did you have any coffee? And the answer was no. So we learned quickly today that if Simon did not have coffee in the morning,
I don't.
You probably don't want to ask him. Yeah, just don't ask him questions in the morning with no coffee.
Yeah, it was painful. So. Why do you want to start blogging? So I started originally, regardless of whether it's being hosted on-prem in the cloud or wherever else, I started blogging, A, to be able to give back to the community, and B, as an online wiki for when I was doing stuff. And it was basically, an online blog. So I could document down the things that I'd learned so I could then share them with other people. Or because I'm forgetful being dyslexic, I would go back and then reread them at a later date. Or if I couldn't remember the PowerShell stuff, I knew that I'd blogged it 3 years ago. I knew where the blog post was. So I would then go and reread the PowerShell that I'd written 3 years ago and go, that's the snippet I needed, and then copied it out. So it's good fun as well. Like I enjoyed writing documents and the flow process and going, this is how you get from A to B. As you'll see later on, at the end of the live demonstration, I've also created a markdown file in the GitHub repo with the slide deck. So if you guys are wanting to try this out for yourselves, you can go look through the README, and it's got all the steps in which I'm going to use for the live demo later on. So firstly, choosing a platform. There are many platforms out there. Too many to list, to be fair, within the slide deck for today. So I went through and picked a couple that I knew of, which are like hosted platforms, and then a couple of self-hosted versions. And this is going to be very high level. I'll be honest and caveat this saying I asked ChatGPT to write these next couple of slides with some pros and cons for each platform from just like a high level sort of thing. So starting with WordPress, I think WordPress is probably one of the most commonly known platforms. It comes in two flavors. There's the self-hosted version, which I'm running currently on my rack of servers in my parents' garage because, everyone likes on-prem stuff every now and again. Or you can go for the hosted version and let WordPress manage all of that for you. And then you can just create the content and get it pushed out there. Then following on in the trend of managed platforms. Oh, hello, Richard. I'm waiting for the heckling to start now. I can see that there's some people from Intercept here as well, like David and Richard, and obviously Wesley's here for other things. Good evening, good evening. So following on that same trend, Ghost is another platform. Now, I believe, Wesley, you have a blog that's written on or hosted on Ghost, don't you?
Yes, but it is the hosted Ghost version. So I pay for it every month. I have to say quite some as well, because Ghost doesn't come cheap. But I am actually looking to replace that with something like static web apps because A, it saves a lot of money, and B, I'm definitely into DevOps and platform engineering. So I do want to, play with that tag as well. So I'm also here to learn today.
Cool, great. It's nice to see Rennie's joined along as well. This is going to be interesting. This is going to be a lot of talk tomorrow, I think, in the Teams Cafe. But no, we're good. So Ghost is another platform. Then in the same trend, there's Medium. Again, personally, I've never used it. I know that there's people out there who write on it. Same again, you could add HashiCorp into this list as well. So like I say, the list is absolutely endless, and I didn't have enough time to go through every possible option. I just went for what are the most common ones that I've known and seen mentioned online and that other people are using. So those are the hosted options. Then you get to the self-hosted options. So the demo that I'm using today is going to be Hugo, partly because Carl Cook, who some of you will know and previously worked with us, built his site on a Hugo, and having been given a load of stick from Richard, Wesley, and Carl over moving to Azure, Carl then said, well, you should start with Hugo, and then was great for giving me some support and pointers on getting started. So yeah, this is Hugo, and then an alternative to Hugo, which I was looking at online and comparing to, is Jekyll. I had a brief look at it, and from the setup and the docs and stuff, like I say, I at the end of the day, I chose to go with Hugo. That said, as I've already said a couple of times, pick a platform. There's no right or wrong way. It comes down to personal preference. Whatever works for you at the end of the day and makes your blogging experience the easiest is the way to go. So that's it. Slide deck done. We are going to go have some fun in the Azure portal. So this tweet from Jeffrey Snover turned up this afternoon while I was practicing the demo and tweeting some bits and making sure that all the GitHub automation and the markdown files all flowed perfectly. He retweeted this, which I thought was really cool. So I thought I'm going to grab that and then put it into the slide deck. So yeah, let's jump over to my shiny Windows 11 virtual machine. So this is a brand new Windows 11 box. So we're going to start from the basis of you've never done this before and you're wanting to get all the packages installed. Again, there is a GitHub link which you can follow, which I will post after this, where you can see the end-to-end process. So to start with, you want to open Windows Terminal as an administrator so we can get things installed. So obviously out of the box, because this is a brand new Windows machine, there's nothing installed. So I've written this little PowerShell wrapper, which will go through and it will install Git, Visual Studio Code, PowerShell 7, and then the Hugo application that we need to build and run things. And this will take a couple of minutes to go through and, yeah, install.
But so far it's working.
Yes, because I checked my demo before we did this, and I've got all the notes in a cheat sheet next to me, so I can just copy and paste. So in theory, providing Azure doesn't have an outage, this should be a seamless demo.
Yeah, and it's not Friday because we tend to have those outages on Friday these days,
Yes.
I guess. Right. I am reading chat.
Yes.
And you mentioned Medium.
I
think we don't have a lot of fans on Medium.
Yes, it looks that way. Apparently, Richard hates Medium.
Well, I'm not a big fan myself, as
Yeah.
it always feels like reading that, that post on a newspaper website, and you go, oh, if you want to read more, then you need to sign up
Exactly,
or pay for it and that stuff. All right, so what are we installing? We're installing the VS Code.
Yeah, obviously, got to have VS Code in there. It's more just for, yes, ease of managing the Git bits when we get to there. But for what I'm going to show, yeah, there's more intricate things you can do, but this is going to kind of like sideline all of that and just go, we have a Git repo, and we're just going to push straight to main, which I know isn't advised, but if you're just getting started and you've never done this before, let's just make it nice and easy so you can get the content up there, and then we can look at a later date, refining it, putting branch protection in bits and pieces.
All right. And assuming this all works, the whole install, and
Yes.
assuming and assumption is and then let's not break community guidelines, but are you going to share this code somewhere that we can take a look at it and do it ourselves?
It's all written. There's a whole markdown file where you can grab the slide deck and
nice.
A full like end to end. So it'll give you all the steps with nice screenshots and text in, which is what I was updating this afternoon to make sure that what we showed today will pretty much or almost match up, apart from some of the naming conventions. So you can basically go, this will work end to end. So install is completed. That's great. So let's close and then reopen this. Then we're going to swap to PowerShell 7 because I had some bugs when testing this in PowerShell 5. Then we need to pre-stage this bit because this is just for Git, which you'll already have done if you already have Git installed. So next, we need to go create a GitHub repository. So we are going to call this static web app demo. It's going to go into here, and then we're going to create this as an empty repository at the moment, which is the important thing to take note of. We're then going to grab this, which is the Git link. We are then going to create a local folder. I like to keep anything, I'm not in Linux, make dark code. I like to add all my stuff under C code because when you're doing stuff with Windows, as we know, there's a file path length, which is incredibly annoying. So I like to keep everything as close to the top of the C drive as I can, just to make, file management easier. So if we then go into here, we'll then type in git clone and then paste in the repository. Which will take a minute or two.
It's an empty repo, right? Yeah.
Yeah. At the moment, it's a totally empty repo. Then what we're going to do is once it's cloned the empty repo, we're going to then, so as you can see here, it says, yeah, we have our empty repo. What we're then going to do is now create the Hugo website. So this will create the site under the C code. I think I need to add a hyphen in there because I left it in. The reason why you need the -- force is because when you're trying to create a Hugo website, when it's brand new, it requires an empty folder. But because we're obviously using Git, we've got the .git folder in there. Therefore, doing the -- force ignores that and lets us just paste it all into there. So I'm just going to double check this is the right, the right folder, and then we'll copy this. And we'll build our initial Hugo site.
So while this builds, or it's already done, just double checking, the Hugo command is the CLI you install with your script as well, right?
So our site is now created. So if we open VS Code, because everyone loves VS Code. So this is out of the box. This is what your static this is what your Hugo site will look like out of the box. If we then try run this locally, bearing in mind this is a brand new Hugo, helps if you go into the directory and then try run it. So if you run the Hugo server command, this then builds the site locally on your machine, and then you can see what it looks like, from your local browser. Which you can see that looks pretty cool, doesn't it? As like a vanilla website. I mean, it works, so but we can make it better. And this I think is probably the hardest thing I find about blogging is I can write all the technical content that I need to, and I can piece all that together. Trying to find a theme that I like is the hardest thing to do. So to make this demo a bit easier, I've already picked a theme and sort of had a bit of a play around with it, so I know how it works for the sake of this. However, if you're wanting to have a look and see what the back catalog is of Hugo themes, if you go to themes.hugo, go hugo.io, there's a whole raft of themes you can pick and choose from. I've spent hours trawling up and down here trying to work out what theme I want for the demo and went, it's a demo, just pick a theme. So I did. And the theme that I went for in the end was this one for the sake of today's demo, which is the Bilberry theme, which shows as the sample does. So to install this theme, again, all these commands are written in the markdown file, which I'll share with you guys at the end of the talk. Firstly, we obviously need to stop the running site. So we do Control-C. We then grab the Git submodule and paste this in. This will then clone the site from GitHub into the local Hugo site. What we then need to do is go to the TOML file and add in here the bit I'm missing from my cheat sheet. Bear with me 2 seconds. I will go to Git and grab it. And what the bit that I'm going to go and grab basically does is it will allow us to add. It will allow us to basically define the theme that we're going to use, and then we're going to rebuild the site, and then you'll see what it looks like.
Are those themes free?
Yes.
Oh, that's good.
Yep. But yeah,
Free
if, for
is good.
example, if I just jump back to here, if you then click on download, this will then take you to the actual like GitHub page where you can see the demo. If you find any bugs or want to make any contributions, you can do. And then there's a whole list of like how to improve the theme. So this is going to be very much, we're going to build Hugo. We're going to create a couple of sample posts. We're going to fire it into a static web app in Azure and stick a domain on it. In terms of customizing it, you could spend hours and hours and hours going through and doing custom CSS and all the color side of things, which I'm not going to go over in this talk. It's very much just going to be, we're going to deploy this and this is going to get you started. But yeah, in terms of the docs, as you can see here, there's loads of stuff. Then there's like Google Analytics integration you can do, audio, video embedding, all sorts. So yeah, so just to recap then, we have now downloaded the theme and we've saved it in the hugo.toml file. So if we now relaunch our website locally, this will then build, and then we go back. Here we have the new site. So we have a site. We now want to create some content on it. So to create new content on it, what we do is we run this command, which is here. And what this will do is this will create a folder under posts, or it'll create a post folder under content. And then depending on how you like to version control stuff. So what I've decided for how I'm going to do the blogging from 2024 is I'm going to do it by month, and then I'm going to date version all the files. So if we run this, for example, you can then see here that it's created the content under the content folder, then posts, then 2023, then the 11th, because we're obviously in November. And then this is the title of the blog post. So if we then jump back into VS Code, then from the left-hand side, go down to content, post 2023, 11, and then open it. This is what we see. So obviously we don't want this to be a draft post because we want this to be live, and then we'll put hello world. Then we can come back and relaunch it. And then go back to here. And there you go. So we've now got our new site with our welcome blog post or your new technical content ready to push to the world. So we now want to go to Azure and we're going to go build the static web app. So here is our resource group. You then want to go to create. We're then going to go to static web app. And then run through. So we're going to call this static web app demo 01. For this, because there's not going to be loads of traffic to it, we're going to leave it on the free tier. We're going to deploy it into West Europe. And then you can obviously deploy, if you want to use other platforms, you can do, but I'm using Git. So as you can see, I've already got my Git account pre-configured. We can then go down to the organization. So I'm going to use the new repository for where the new organization, sorry, from where I'm going to put all my new stuff for next year. We're then going to come down to the static web app demo. Ah, yes, I missed the step of pushing the code to Git. That might help. So let's backtrack a little bit. We have created Hugo. We've got the Git repo, but we obviously now need to push all the contents to GitHub to be able to complete this step. So I have compiled this, which will add all the files within this repository, create a Git message of static web app upload, and then push it all to Git. So there we go. We've now pushed this to the main branch. So if we come back to here and refresh, here is our new site ready to go. So what we now need to do is come back. We need to restart this, or we might be able to get it to refresh. If not, we'll cancel out and go back through. Yeah, there we go. And then you can come through and pick your build presets. Now, as I said, when we were looking through the slide deck, there is lots of different options that you can pick depending on what you're wanting to use. But for us, we're going to use Hugo. And then we're going to come through and, yeah, leave all this as default. If you want to tag it, you can do for either billing or monitoring purposes. And that's it. Static web app is ready to deploy. So we'll go through, and this will take a couple of minutes. So what this is doing is it's deploying, obviously, the Azure side of the static web app. Then also in the GitHub side of things, it is then creating a GitHub action, which we'll see here in a minute or two once it's pushed it to it. And then we can see the build process.
So, Simon, you did the hobby and free personal scoop.
Yes.
If my blog takes off, right, and it's obviously we always assume that's going to be immensely popular, I can just change the scoot to something more.
You can
beefy,
do. You
right?
can change it to the standard SKU. You then have to give Microsoft some money though. But if you're doing really, really well though, you could obviously with your Google Analytics and AdSense stuff, if it monetized, it could potentially pay for itself. Yeah,
All right.
which is definitely an option. So let's see if this is, yes, this is done. Brilliant.
Oh, look at that.
So yeah, there we go. We now have a site that is building and it's now, pushing to Azure.
All right. So it's basically whatever you just push to the repo.
Yep.
It's going to deploy that. So while we wait for this, any reason why I would use a static web app? I mean, I'm like, I've been in this job for a long time. I always did web apps. Never did static web apps. Why would I do static web apps?
So for this scenario, for example, what we're creating is obviously static pages because it's blogs with just text and image. So because there's no moving parts to it, it literally deploys the static content into the web app, and then that's it. If you wanted something slightly flashier, then I'd probably say maybe look at going down like an app service route, which then gives you obviously an underlying operating system, which you can do more with. But obviously the caveat to that is you do more, there's obviously more of a per monthly pay more for that. So it depends on what you're wanting to do. If you're wanting to just do blogging like this, for example, static web apps are brilliant. What I also found the other day while doing some community stuff is you can also get Hugo deployed to GitHub pages, which I didn't realize or know about, which is something that I'm going to cover in January on how to do. It's kind of the similar sort of process where you create an action and it does all the work for you. But if you don't have access to an Azure environment at the moment and wanting to get started with blogging, you could do a GitHub pages site with Hugo and then just point the DNS to it. And then the only cost that you've got is just the domain.
Nice.
I see Luke has also found this and is running Jekyll on his GitHub pages site. So there we go. So this is now completed, which is all good and fine and fun. So if we now have a look at this, so this is obviously your overview for this. We can then, it should give me a domain. Yes, down here. It's moved around. The Azure portal, people, changes every day. So as you can see here, this is our site all ready to go. So if we click on this, here is our site. However, you might be asking, well, this looks totally different to what we've deployed locally. Why is this? So this is where HTTPS and SSL things come into play. So if we go back to our Hugo TOML file, we can say that the base URL is https example.org, which is the default site you get when you create your Hugo site, which if you don't change, which I learned the hard way, it does this and breaks it. And if you look in the bottom left at the moment, you can see that the HTTPS links are all pointing to the Azure Static Web App and not the domain that we want to use, which is a nice segue into we're now going to add a custom domain to our web app. So it then fixes it, because obviously when you're blogging, you want to build your personal brand, which you can use for Twitter, LinkedIn, YouTube, Twitch, pick a platform, and go from there. So to rectify this, what we need to do is first is do a git pull. And why do we need to do the git pull, Wesley? What has changed in the repo since we've pushed to it?
I just quickly mute myself. it created the GitHub action. So the .github folder, you want to make sure that's locally, because if you push new stuff, you break the action.
Correct. So when I
You
was
put
doing
me
this,
on the spot there, buddy.
I know. Hey, you did really well. But the reason why I put you on the spot was because when I was doing the practice for the demo, I forgot to do that. And I got a git merge conflict saying, hey, there's changes in git. I was like, what is that? And it was, oh, yes, the action. So git pull first. What we're then going to do is we are going to create a new domain, which is somewhere, which is going to be up here. So in our Hugo TOML file, we're going to call this demo-swa.cloudadventures.org. What we then need to do is update the build and go updated base URL. This will then push the changes, rebuild the site. While this is rebuilding, we can go back to the Azure portal, go down to custom domains. And then this is where we will add our custom domain. So for the example that I'm using, DNS is managed within Azure, so it makes it really easy to do. It will do all the validation for me. If you're using external DNS, you'll have to create the CNAME and a text record to obviously prove that you are the owner of both sides of the domain. So if we paste this into here and then click add, this will take 30 seconds or so, as it's using a Let's Encrypt certificate in the back end, which does it all. While I was watching this, you realize how long demos actually take when you just sit and watch a spinning window go around for 30 seconds or so. So yeah, we basically just have to wait now. This will then go through, and then we're pretty much there for the demo itself. While we're waiting for this to deploy, are there any questions? I can see Rinny's got a question around, are there any SLAs for static web apps? That is a good question. Wesley, do you know the answer for it? Not wanting to put you on the spot.
You need the standard SKU for an SLA. The free one doesn't have an SLA. I think for blogging that's fine. You definitely do not need 2 instances and traffic manager and all that stuff. If you were to go down the road of Azure App Services and web apps, then you definitely do. Static web apps, not so much. I think it also really depends on what you're hosting on there, whether you want that SLA. I think for blogging, that'd be fine. We've also got customers running documentation sites on static web apps. You definitely want to look at a more beefier version of this.
Yeah, cool. So great, that nicely filled us in for completing the custom domain.
Well, you know it's a live demo, and whenever something goes wrong, it's DNS, right? So
100%. So once you've then added your custom domain, if we then go back to the overview and then hard refresh the Azure portal page, because it never updates properly, you should then see that your domain here is then changed to be our more user-friendly domain. And then if we click on this, interesting, it should have then changed. Why have you not changed?
it's always DNS.
Always DNS. And then you get a nice, pretty site.
Did you change the site name to that exact? Oh, you did.
Yeah, no, that's right.
Maybe it just takes a little.
Maybe. Wouldn't be a live demo if it didn't work, right?
It's DNS.
Well, if it was DNS, I'd expect the site not to load. But if I put this in chat, can someone try get to it externally? Oh, I would. Oh, let me try paste it in from here.
Let's have a look. See. Is it demo? I'm gonna try as well.
So it's not just my PC. Okay.
Demo SWA.cloudadventures.
Oh,
Something.
interesting. What have I done here?
We broke it.
I've broken something. Because looking at the URLs, I've got 2 of them in there.
Ah.
Interesting. Why have I got 2 of them?
So how do we debug a static web app?
Yeah, this is, very much so. So, and this obviously, this wasn't planned. The demo I did 2 hours ago was flawless and gave me what I needed at the end of it. So let's check and see what the branch is doing. So this all looks fine. That's in there. Let me go see what I put in the docs. Is it because, does it need double slashes in? Is it a formatting issue? I think this is a user issue. So we'll do this and then we'll let this rebuild and see what it does.
So the GitHub action you have, it runs on every push then to the main branch.
If we look at the GitHub action while it's doing its stuff. So obviously when you create the static web app, it then pushes this into the repository. And basically if you push to main or open a PR request, it will trigger for you. And I was having a conversation about looking at using deployment slots for this, but because obviously you can build the site locally on your machine, I was like, well, I can see what the changes are because I can obviously build the site locally using Hugo server, see what it's doing, and then just push that straight to Git. So yeah, we'll just wait for this to finish pushing. So yeah, as you can see, it basically checks out, pushes the code, it's then finishing the upload, and now it's rebuilding the site.
So it's building. Does Hugo need any building? Does it builds it based on the config files you provide?
Yeah.
It generates something, and that's what's generating the static web app then, or the static pages.
Yep.
I think you fixed it.
Yeah.
I think you did.
We'll find out in a second.
Well, I'm just clicking a lot of Control F5.
Let's see.
The main page, yeah. Works on my computer.
Oh, does it?
It definitely works on my computer. Welcome to my blog, Hello World.
Nope, I've got DNS issues.
Well, you're in the UK, but it works in the rest of the world.
Nice.
It definitely works. Demo SWA, welcome to my blog, Hello World, exactly like you have it in config.
Yeah, there we go. Edge doing stupid caching things. So yeah, there you go. We've done some live debugging, and apparently, yeah, it works around the world, just not on the VM that I'm doing the demo from. But yes, here we go. So there we go. That covers the principles of building your site, having some live demos and debugging. Then, like I say, for the slide deck and bits and pieces, I will post in chat. There is a whole repo which you can go and look at, which I've put all this in, and it gives you all the PowerShell code that I've used today, getting started, creating the repo, and then some troubleshooting steps, and basically everything that we've just covered live, apart from the debugging, because the demo gods apparently weren't with me today, even though I did all the prep and the sacrifices, which is always fun. It always makes it more interesting when the live demo goes wrong. But yeah, like I say, I'll post this link in chat, and it basically covers through, as you can see, same thing, concept of creating posts, creating new posts, how it looks in the folder, pushing static web app deployment, and then adding the custom domain, and yeah, there you go. Cool. Well, that was the demo. Do we have any questions? Would be my my last point, and if not, I will hand back over to Nicholas and Kevin.
Good job, Lee, Simon. So you actually did some troubleshooting, so it's well done.
Yeah.
The first demo.
Yeah, brilliant, Simon. We were only talking about this before we kicked off. The live demos are what makes these sessions, I think, more special.
Exactly.
It would be too easy to just record it and just play a video, right? It'd be way too easy.
Yeah, definitely.
Yeah,
it takes all the fun out of it. You've got to do it live.
Every single person who would do something like this would have those issues, and even the issues that you faced previously when you were kind of building up this demo. I think the troubleshooting and the debugging on the fly is awesome. Well done. I know it was only a simple demo, but you know, these are the issues that every one of us techies see on a regular basis.
Exactly. Yeah.
So well done. Brilliant.
Yeah. Cool.
There's no additional questions. A lot of support. A lot of people blaming DNS. Not many people, as Wesley said, who like Medium. But I think, like some of the chat, I hadn't heard of Ghost, and it's kind of ironic that we talked about a Medium and a Ghost in the same chat, right? But I thought it was really cool, and you make some compelling arguments for static web apps from for blogging perspective, right? So there's a lot of bloggers out there. And you want to kind of do it at that low cost, kind of, I won't say low effort, like from a non-dev, like there's a little bit to wrap the head around here. For me, you've got your GitHub, you've got some samples, we'll share the content, and obviously this is recorded as well. So folks on the chat and anybody watching this after the event can obviously revisit the video and have a look at the step-by-step for you as well. So
I've got a question, Simon. It's a small question. How would people migrate from like GitHub pages to static web apps easily?
Well, if you're using it in Hugo, for example, it's pretty straightforward. You can basically just build a static web app and you just point it to the Git repo. Trying to do a migration from WordPress to Hugo, I haven't yet worked out. So I basically decided I was going to leave the old site as it is, so people can go and see the stuff that's written there for like Hyper-V and Windows Server stuff from back in the day. But there'll be no further updates to that from like the end of December. And then, come January, there's going to be this all brand new cloud blog written in Azure and all things cloud. So,
Okay. Brilliant. So Luke said, chalk Cloudflare in front of it.
Yeah, that's additional options and probably cost as well if you're putting something like Cloudflare in front of it.
Yeah.
Cloudflare is an awesome product, right?
Yeah.
Definitely.
Because I noticed that you can use it with Azure Functions with the API. Like you can get API and then apps as a separate one to debug it. So that's so good. Okay, thank you, Simon and Wesley. Thanks for helping.
Thank you. Cheers. Thanks, guys.
So it's going to be Johnny.
Johnny up next, yeah. Hey, Johnny, can you hear us okay, yeah?
Yeah, I can hear you perfectly fine. Good evening.
Awesome. Thanks, Johnny. Do you want to give a rundown on what your session is and get started whenever you're ready?
Yeah, I'm ready to go. My session is just going to be about Azure Container Apps, as I promised. I made a small little presentation to do a little introduction. As you can see, I stole your logo from the Meetup website. And maybe first I'll talk a little bit about who I am and what I'm going to do, of course. So let's see. So yeah, my name is Johnny Hooyberghs. You already announced me a little earlier this evening. I am a developer, .NET developer from Belgium. I'm actually a consultant working for a consultancy company. A couple of years ago, my boss, the one who hired me many years ago, I don't know, got sick of me or something. He left the company, and he basically asked me to take it from him. So I'm actually partly a software developer consultant, and the other part, I'm actually the operational manager at the company I work for involved, which is fun because I can do both things, and I like a little bit of action in my work. I've been developing for a long time now, since 2006. I've always done .NET, also in my free time when I was younger. So I'm still doing .NET today, which I really like. And I have a bunch of hobbies. Basically, I have not a lot of hours in a day to do everything that I want to do. But yeah, whatever. I like traveling, and I actually like to visit as many theme parks as I can. So I've been to the UK many times to visit all the great theme parks that you guys have over there. The things that I'm going to show you today are also available on my GitHub. So you can see a QR code on this slide. You can see a link in the bottom for all of the slides that I will show you. Everything is already there. I have a very small piece of code that I'm going to use in my demos. Most of my demos will be in the Azure portal. And then a copy of my slides is also there. So everything is already there. If you want to copy it, if you want to use it, you can do whatever you want. It's free for you to use, basically. All right. So with that, I want to do a very quick introduction about some of the things that I mentioned in my title. I told you in my title that I would be talking about deploying or hosting cloud native applications in .NET to Azure Container Apps. So I'm very quickly going to do some background information about a couple of things, and then most of my session will be me just working and clicking around in the Azure portal to show you all of the different options and the different possibilities we have on Azure to do container apps. So first, when I was preparing this session, I was looking into what does cloud native actually mean, because cloud native is one of those words you hear a lot these days. And I found this little, let's call it a definition. It says cloud native is a microservices hosted in containers and or serverless apps that can run in multi-cloud environments and are managed by DevOps processes. That sounds like a lot of bullshit bingo there, because there's a lot of these words in there that you hear quite often. These words are things like microservices, containers, serverless, multi-cloud, and DevOps. So again, I'm very quickly going to touch on these points and how they are linked to the things I want to discuss today in Azure. But before I do that, I also promised to do it from .NET 8, but it doesn't really matter if you're building cloud native applications and are using Azure Cloud. You don't really have to use .NET. You can basically use whatever platform that is also cloud native by default. So in the case of .NET, it can run on Windows, obviously, but the new .NET versions, the versions from .NET Core onwards, and the current latest version is .NET 8, it actually came out 2 weeks ago, runs also on Linux or Mac or a lot of platforms and a lot of processor architectures. It obviously runs in the cloud because the cloud also uses computers and servers to run everything on. It also runs on IoT devices because IoT devices also use or Windows or Linux as operating system, and they use the x86, x64, or even ARM processor types that we can use to run our .NET applications on. I told you before, it doesn't have to be .NET exclusively. You can. There's many platforms, many programming languages out there that support applications that can run in the cloud. So this is a big part of the cloud native story. You can do Java, you can do Node, you can do basically whatever language you want. Also, the .NET SDK itself, so the tools that you are using, are not bound to a specific operating system, and the .NET SDK is even not bound by different tools. Some people like to use Visual Studio, some people like to use Rider by JetBrains. .NET doesn't really care. Microsoft probably cares, but .NET itself doesn't really care. You have the .NET command line utility. You can use that from wherever you want. You can use that from your own PC, you can use that from a remote PC, you can use it on Linux, Windows, again, all kinds of different devices, even automated scripts that use the .NET SDK to build and test all of your code in a cloud environment, in a container environment, doesn't matter. So you are not bound by these restrictions. Very cool. Then next is microservices. Again, one of the buzzwords we hear a lot these days, microservices. The definition again is something like a collection of loosely coupled services where services are fine-grained and protocols are lightweight. What does that mean? Well, basically, you split up your application in different applications that work together. All of these different applications or services, as we call them, are fine-grained, which means that they only do what they are supposed to do. It's like a little bit the concept of the single responsibility. Each of your little applications or services, they have one responsibility, and they are very good in fulfilling this responsibility. So fine-grained. Protocols are lightweight is basically like all of these services need some way to communicate with each other. The protocols we are using, the technology we are using to do this communication should be lightweight so that it can go fast, that it doesn't use a lot of resources. So that's the idea. Of course, you hear the term microservices everywhere. Again, it's kind of one of those buzzwords. What you decide your microservice is going to look like is basically up to you. You need to make that decision based on the kind of application that you build. Maybe you don't want to do microservice. Maybe you just want to create a distributed application that exists out of a couple of applications that work together. Maybe in theory, those are not microservices, but you shouldn't really care. You just need to find the solution to your problem that works best for you, that works most performant to you, which is just perfectly fine. Again, microservices is not something you need to do. Microservices is something you can do. And also, when you're using a monolith architecture, when you're just creating one big application, that can also be perfectly fine. Again, if your use case asks for something like that, just go ahead with it. If it works perfectly fine for you as a developer, but also for your users, that is no issue. You can also build a monolithical application in the cloud in a cloud native way without any issue. Next are containers. This is of course very important to understand before I go into container apps, of course. So the definition for containers is a standardized unit for developing, shipping, and deploying a software package to run quickly and reliably independently of computing environments. So yeah, again, that's a lot of words. Basically, the idea is very simple and it's very comparable to what we know as containers in the real life world. If I go back 100 years, when we wanted to ship things using a ship, in this case, an actual boat, you buy something from Amazon 100 years ago and a boat needs to bring it to you. We didn't have the idea of a modern container, like a shipping container like we have today. So the problem there was it was very hard work to put all of these things on a ship, for example, because you have barrels, you have bags, you have a sack, you have a box, all different kinds of stuff. And you need to fit it in the ship in a performant way, and you need, of course, a lot of manual laborers that are actually putting all of these things on a ship. So very difficult. The reason we are using shipping containers today is because when we use a shipping container, we basically create a standardized way of shipping stuff. And in this case, I'm using containers on ships, and a ship will be built to exactly hold a number of containers, and they can be stacked, and that will be an optimal usage of space and resources. And it's also very easy to put these containers on the ship because we have devices that put them on that, and those devices are created specifically for those kinds of containers because each container has a specific width, height, length, stuff like that. Next, we can also put these containers, of course, on lorry trucks or on trains. We have just created a standardized way. And to be honest, people who are working in the transport sector, like working on ships or shipyards, working on trucks, driving trucks, these people don't really care what is inside of the container. They just want to ship container from place A to place B. So they don't care what's inside of the container. It can be plushies, it can be food, it can be cocaine. Again, the truck driver doesn't really care what's in the truck, what's in the container. And with software, we want to do the exact same thing. So with software, when building an application, if it's like a very complex .NET application that does a lot of backend stuff, or it's Simon's static web app from before, if we put both of those apps inside of their containers, again, the people who need to put that container into a cloud environment to be able to run it for our end users, they don't really need to care what is inside of the container. Again, it can be the static web app from Simon, it can also be my .NET app, but it doesn't matter. It just needs to run in an environment that uses a standardized way of hosting these containers. And that's the idea of using containers in software. Very similar to why we are using them in transportation. Now, of course, when you put your applications inside of a container, you as a developer need to look for which dependencies should I include, what is the platform my application needs to be running on, how should my application be configured, and how should I configure the data access, for example. All of that stuff is up to you as a developer to configure, and also put all of that inside of your container in some way so that the people that need to deploy your container don't really need to think about that, and they can just run your application in the cloud and it should work perfectly fine. So that's the idea. So the examples that I'm going to present to you today are going to use these kinds of software containers. Now, of course, my example is not going to be so complex as the picture that I'm showing you here. It's probably going to look a little bit more like this. I'm going to create a couple of demo containers, and I'm going to string them together so that they can work together. But of course, you get the idea. When you build large-scale applications, large-scale distributed or even microservices applications, you have a lot of these little applications that need to work together, and this is how you can do it. I'm going to show you how you can do that in Azure. Now, building a container is actually pretty easy. We have different kinds of softwares that help you with that. One of the most used is Docker. People use Docker instead of the name container because Docker is synonymous with containers today. But there's also other tools that can help you to do the same thing. So in here you see a very little script called a Docker file. This is actually a script that creates a Docker image for you, a container image. And the container image contains all of the files and all of the configurations that are needed to package your application in a container. We call this an image and not a container. The image is the representation for the content inside of your container. And then when you run the container locally or in a cloud environment or on some kind of server, that is when we call it a container, when it's actually a running container. Here you can see very easily that we are basically building a container from a base container. So with containers, the idea is that you start from a spot, a place, or a base container that already contains some of the dependencies that you will need. So when I build an ASP.NET 8 .NET application, I'm not going to think about all of those dependencies myself. I'm just going to ask Microsoft, please provide me with a container image that already contains the runtime for ASP.NET version 8 and all the dependencies that this runtime has, because the ASP.NET runtime also runs like a web server, for example, in order to host your ASP.NET web application within this container. So the dependency to the web server is already a part of this container image. So you're just using that, and you're basically adding your own little software to those to that container image, creating a new container image based on the previous container image. So again, we use the ASP.NET 8 container image, base container image, and as you can see, we are creating a working directory called app, and we are copying our application from our own published directory into this app directory. So we're adding our application to the ASP.NET runtime Docker image. Then we are configuring some configuration. We are exposing port TCP port 8080 so that we allow incoming connections through this port. We are setting some environment variables like the time zone. Maybe I have a connection string to Azure Key Vault. Maybe I have some other custom environment settings that I want to use to get some information or configuration into my container. And then finally, I am specifying the entry point. So the entry point basically tells the container runtime when you run this container. And when you start this container, please run this little script. And this little script just does .NET my custom web app.dll. So .NET is the .NET runtime executable, because .NET is a runtime and not a native platform. We need to use .NET to run our custom DLL, and this will then be just in time compiled into the native code that is necessary to run on your container environment. So that's the idea of containers, obviously. Then we have some more of these buzzwords like serverless. So thanks to cloud computing, scaling, capacity planning, and maintenance can be hidden from the developer or operator and focus on your application, not the infrastructure. So again, the idea is we are not using servers, we are using managed cloud services. So we as a developer, or we as a person that needs to deploy all of these things, do not need to think about all of the infrastructure. We just need to focus on our applications and the configuration and how we run them in the cloud, but excluding the actual infrastructure. So yes, serverless is not without servers. Of course, there's always going to be servers, but we are not the people managing those servers. We are just using the cloud services, and the cloud provider, for example, Azure, they will manage the servers, they will manage the updates for those servers, they will manage the security. But we have an easy life. We can just use those services and hope for the best, of course. Then we have multi-cloud, the use of multiple cloud computing and storage services in a single network architecture, and the ability to be cloud agnostic, which basically means that if you're creating or building cloud native applications, you don't really need to worry about which cloud you are going to run them on. The things you create should be cloud agnostic. Now, if you're using containers, this is very easy, because all major cloud providers already have support for containerized applications. So you can build your Docker containers or images, and you can run them on different cloud providers. Azure is, of course, one of them, but there's many others. So yeah, there's cloud is everywhere these days. You can put something in a container and basically run it wherever you want. Just like when you drive your car, you see trucks and containers everywhere. And then finally, we have DevOps, which is a set of practices that combine software development and IT operations to shorten system development lifecycle and provides continuous delivery. So yeah, again, DevOps is where we just combine the development and the IT operations into one single team, or even one single person. And of course, when we do things like putting applications inside of containers, creating these kinds of cloud native applications, we are basically also putting together these different roles, because you as a developer have to think about your application itself, but you also need to think about the dependencies. Is your application dependent on some systems? Is your application dependent on some platform? You need to take that into consideration before putting it into a container. And this is actually a part of the operations idea. And when you deploy them to the cloud, you obviously also need to think about what kind of cloud service am I going to use. Again, you can do this together with some people who know about operations and know how cloud systems work, or you can do it yourself just using these services within the cloud that are serverless. Yeah, and this is just a fun meme, like many of the others that I included. So let's skip that. And then, of course, the point of the story that I want to tell today, Azure Container Apps. So everything that I told you just now, when we are using containers in a cloud native way, how can we put those on Azure? Well, there's multiple ways, but Container Apps is one of those ways. And Microsoft itself describes Container Apps as a fully managed Kubernetes-based application platform that helps you deploy apps from code or containers without orchestrating complex infrastructure. So you can already see the word Kubernetes. And again, Kubernetes is something that we've been hearing for many years now. So what is Kubernetes? Well, basically, when I go back to the concept of containers, everything is fine and dandy when you're building one single container. You're creating an application, you put that application into a container image, just like I showed you, and you're running this into a cloud or in a cloud environment. Okay, perfectly fine. But I showed you this image where multiple of these containers or services or applications need to work together as a distributed application, or maybe as a microservices application. So we basically have multiple of these running containers that need to work together. How are you going to orchestrate this? And Kubernetes is something that was built a long time ago that will help you to orchestrate containers. So what is Kubernetes? I'm not going to dive into detail about Kubernetes because Azure Container Apps will do that for us. But I'm just going to talk about the basic concept of Kubernetes. Kubernetes is basically a technology that helps you to orchestrate and manage all of these running containers within an environment. And the Kubernetes environment itself is made out of different virtual machines. So you have multiple virtual machines that exist locally, maybe in an on-premise environment, but they can also exist in the cloud. You can use Azure Cloud, for example, to just create raw virtual machines. You install an operating system on there, and you can install whichever software you want. So you can install Kubernetes on multiple of these virtual machines. You can configure those as a single Kubernetes cluster, and then Kubernetes will run part of its own system, its own management system on those virtual machines. And we call those virtual machines nodes, different nodes in the same Kubernetes cluster. Now, these nodes are nice because we can actually run Kubernetes itself, but also our own application in an agnostic way about which VM should I run my containers on. We don't really care. We basically ask Kubernetes, please run these containers for me. And Kubernetes will put them or run them on a node that has still some capacity available, still some resources available. And this is where the power for Kubernetes comes from. Kubernetes will decide where to run your containers. You just need to configure which containers you want to run, how these containers should communicate to one another, and how these containers should be scaled. And scaling is also very important in cloud native application design. You should design your applications that they can be scaled easily. And then in Kubernetes, you can basically define this part of my application or this microservice should be scaled like with 10 instances. It should run 10 replicas, which means that the same service is run 10 times at the same time next to each other, horizontally scaled. And again, Kubernetes will put all of those instances, all of those replicas on the nodes that are still available, and it will do that for you. And you can include scaling rules that it will scale up or scale down depending on the resource usage, the amount of requests that come in. So this is what we call container orchestration, and Kubernetes is a technology that can help you with that. But of course, this is quite complex. In order for you as a developer or an operations guy or a DevOps guy to actually configure all of this, keep it up to date, and make sure that everything keeps working is quite hard. It's quite complex. You need a lot of work to actually manage that. And this is why Azure decided to create something called Azure Container Apps, again, as a serverless offering to make sure that you do not need to worry about all of the operation stuff, that Microsoft will manage that for you, but you can of course use the good things about this, the things that we really want, the scaling, the multiple containers talking to each other, all of those fun things, obviously. Now in Azure, there's multiple of these offerings already available. Simon was talking about static web apps. So I don't think static web apps can run containers. Maybe they can. I haven't looked into it. But for example, the Azure App Service, the one that can be used to run dynamic applications, applications that can use runtime like .NET, they already have an offering for containers. So when you're deploying your application as an app service, you can actually choose to run it as a container on your app service, which is very nice. You can run a single container on an app service just fine today. And it's the same with Azure Function Apps. So an Azure Function Apps is again the serverless version, where you just can run a piece of code serverlessly. You can also run these applications as a container, as an Azure Function App container. So those are available for you. If you just have one simple container, you want to put everything in containers, you can already use app services and function apps. Then the next step, there is something called Azure Container Instance. And the name already says it, it's a container instance. So it's one instance of your container, which is actually the same like an Azure Function App or an app service. But this one was the first pure container thing that was available in Azure. Container support for app services and function apps came later. So actually I should switch those two around. Then we have Azure Container Apps, which is the thing that I'm talking about today, which is basically a better version of Azure Container Instances, where we can run multiple containers within a container app, but we can also run multiple container apps together in an environment and really make our environment run our distributed application or microservice. And then finally, we also have Azure Kubernetes Service, where we have a managed Azure Kubernetes offering, but we are still responsible for configuring the Kubernetes cluster. We are still responsible for keeping our Kubernetes cluster up to date with the latest updates. So that's the complex thing. So you can use that on Azure, of course, but if you want to have Microsoft manage that for you, you can of course go to the Azure Container Apps. So I think I've already talked for quite a long time. I hope you're not already asleep. Let's say that I'm just going to open the Azure portal and I'm going to show you what Azure Container Apps can actually do. So let's see. Of course, when there's any questions, you can just interrupt me. Somebody can interrupt me and ask me the questions while I'm searching for my browser. There we are. So I have created a little resource group in my Azure portal for tonight, and you can actually add some resources to that, or I can add some resources to that, and I can search for container apps, container app. There we go. So Container App is the serverless hosting service, blah, blah. This is basically the thing that I just read out loud to you. So I can click this resource. I can create the Container App. And now I need to configure it in the same way you need to configure lots of these Azure services. So you pick your subscription, you pick your resource group, and you provide a name for your web app. So a Container App, I mean. You can do something like this. So here is where the fun begins. So I'm creating a container app. I'm providing a name to this container app, and immediately I need to also provide an environment. So I told you that if you want to really orchestrate your application where multiple of these containers are working together, you're going to need an environment. And this environment is basically that. So the container apps environment can contain multiple container apps, and they can all work together. Because basically those container apps that live in the same container environment, they share a private virtual network. And because they share a private virtual network, they are able to talk to each other. And you can block off this network so that no communication from the outside world can reach into your environment, and you have a safe environment where these container apps can all discuss some things with each other without nosy people from the outside looking in, which is quite cool. And this is the same thing as what Kubernetes does, but in a managed way that is very easy to understand. So again, we have the environment, we put multiple container apps within the same environment to make sure that they can all communicate with each other. That's the idea. So you need to create this environment, or you need to use an environment that already exists. I'm going to create a new one to show you how this works. You also give your environment a cool name. So this is a pretty cool name, I think. And you specify what the kind of environment type is you want to create. So today in Azure, we have two kinds of environment types that we can create. We have consumption only, which is a purely serverless offering, which means that when you run your container apps, you can specify how much CPU and how much memory your container app will need to use, and you can scale that automatically. And you can even scale that to 0, which means that if nobody is using your application and no HTTP requests are coming in, it can automatically scale down to 0, which means you're not using anything, which means you don't pay anything, which is quite nice. So this is a purely serverless offering. So you're not really looking into servers, you're just looking into how much CPU and memory do I need to use per instance for my container app. And if nobody is using my container app, scale it down to 0 and you're not using anything. You are quite limited in what the memory and CPU is that you're going to use. I will show you this in just a couple of minutes. But because you are limited, you also have the option to select the workload profiles. So the workload profiles basically give you some more flexibility on which nodes your container environment will run. As I told you, from Kubernetes. In Kubernetes, you basically define all of the virtual machines you're using as nodes to run your cluster on. So for Azure Container Apps, you can also do that. You can basically specify, this is the size of my node, and this is how many of these nodes that I'm going to use or have available. And then when you create your container apps, they will run on these nodes, and those nodes will always be available. So you will pay for those nodes always. I can actually show you. If you select consumption only, you have just basics, monitoring, and networking. But if you select workload profiles, you have an additional tab called workload profiles. And here you can actually, by default, you always have consumption, which I forgot to mention. With consumption, you can have up to 4 CPUs, 4 cores, and 8 gigabytes of RAM for your container environment. Now you can add workload profiles where you provide again a cool name for your profile. Then you choose a size, which is basically the size for your virtual machines. When you choose a size, there's some profile sizes, and there's the ones that are more focused on CPU, and there's the one more focused on memory. So you basically define, I need virtual machines of 4 cores, 16 gigabytes of RAM, and that would cost me about 300 euros a month. And you have them in different sizes. So you select based on this. Let's select one. Sorry. There we go. And then you specify the amount of nodes or how many instances of virtual machines do you need. You can go minimum 0 and maximum 20, which basically means when your container apps scale up, they will be able to scale up until the point you basically have nodes available. So if I have 20 nodes, I can have many of my container apps running until I run out of nodes and I have no more resources available to have new container apps running. But this is also auto-scaled. So again, if your container apps scale up, they will use more nodes up to the maximum you defined here. But if you use less and they are scaled down, your amount of nodes will automatically also scale down, and this can also scale down to 0. Although they will tell you it's not recommended to go below 3, because basically your container environment, all of its internal workings, so the things that make it work, the things that make the scaling work, also run on these nodes. So if you have 0 and you get a request in, it needs to scale up to 1 and everything needs to be initialized, which takes some time. So you will have a long delay if you need to wait for that. Again, but if I go back to my container app and creating your environment, you have the flexibility of doing a lot of these things yourself using the workload profiles, and you can create multiple of these profiles next to each other. So you can have, like, in the same container app environment, you can have one profile that supports CPU based nodes or instances, and another one that's more memory based. And if you have a very specific subscription in Azure, you can even use GPU based nodes that have a lot of powerful GPUs where you can run specific GPU workloads. So you can mix and match all of those in a single container apps environment.
Sorry, Johnny, I've got a question just for myself.
Yes.
You know, for the workflow profile, when you scale to 0, will it charge you for any?
No, it will, for the workload profile, it will it will only charge you for the exact number of instances it's running for the specific profile you selected. So if I'm telling you like the 300 euros a month, if I select it from 3 to 10, you will at minimum pay for 3 of these instances and at maximum 10, depending on your workload. But if you put the minimum one to 0 and it scales down to 0, you're not paying anything.
Okay, so if it's scaled to 1 and you have a large screw size of the profile, do you still pay less because it's scaling down?
Well, if you in workload profiles, when you select, for example, a very high one, this one, 3,000 euros, and you put it to 1, like this, you will always pay those 3,000 euros a month, always.
Okay.
If you put it like this, you don't really know. Depending on how much usage you have, you pay 3,000 or you pay 6,000. There's nothing in between those two. You pay for 1 instance or 2 instances. Of course, you don't pay it per month. You pay it per minute or per hour. I'm not sure, or even per second. So you pay a part of that depending on when it's scaled, of course.
So I think is it possible to like automate the profile switching? Like, for example, if it's like in the nighttime, you switch to a different profile. In the daytime,
no. You can only specify based on the container app you're running within this container environment. Each container app runs on a specific workload. So maybe you have like a distributed application that has one, or a microservices application that has one service that heavily uses GPUs. Then you would create a GPU profile and you link that container app to that profile. It will always run on that profile. And you have another one that is heavily relies on memory because you're doing a lot of processing and a lot of things that need to be kept in memory. So you link that application to that profile, but you can't dynamically switch profiles based on time.
Okay, nice. Thank you.
All right, so that's the idea about container app environments. So giving you the flexibility to build that environment to then later add your apps to it. But if you just like playing around with this, if you never used container apps before, just use the consumption only version. This one is very easy. You don't have to think about these profiles. You just have your basic offering, and you always pay the same kind of money, which I will talk about a little bit later. Let's go back. Yes. Fuck. One click too many. Yep. Then in the next step for your container app creation, you need to specify where your container comes from. So you created a container image somewhere. You need to deploy that. So you can use a quick start image, which is just like an hello world application, or you provide a name and you select if your images are stored on an Azure Container Registry or on Docker Hub, for example. If you don't know what a container registry is, it's just like a NuGet feed. You basically have a feed or a registry that contains all the images, and your container app will pull those images from that registry. So Docker has a public registry called Docker Hub. You can put your images there, but then they are public. You also have a private support for that if you pay Docker for it. But on Azure, you also have the concept of an Azure Container Registry, and this is what I'm using. So I have actually defined an Azure Container Registry. This one contains a whole lot of images, so I can just select a container image and then a version or a tag for that specific image. And then you need to specify how many CPUs and how much memory this specific container app is going to use. And if you use the dedicated workload, if you use the one based on usage, this is all the options you have. So you can do like a quarter of a CPU, half a gig of memory, and all of these combinations. So that's what I told you about. You're quite limited in how many options you have. When you use your dedicated profiles, you have more options, and you can do that. The reason you have like a quarter of a CPU is because, of course, you can run multiple container apps or multiple replicas, instances of the same container app to fill that up. And some services don't really need a full 100% of a CPU. They're perfectly fine with 25% of CPU usage, and you can basically run 4 of those apps together on one single CPU core. But you need to make this decision beforehand how your application needs to run, obviously. Then the final thing that I want to talk about is ingress. Ingress basically means if your application needs access via HTTP or TCP. Maybe your container app just is running some things in the background and is communicating with an external service, then you don't need ingress. You don't want people to be able to talk to your service. You just want your service to do something and then maybe write the results to a database or something. Then you don't need ingress. If you're creating a web application or a web service, then of course you need ingress. You enable this and then you define if the ingress is only limited to the container apps environment, which means that only the container apps within the same environment can talk to each other, or you can accept traffic from anywhere, also outside of your environment. So if you have microservices that need to talk to each other, you are perfectly fine with limiting it to the container apps environment itself, because now they can talk to each other, but nobody can talk to them from the outside world. Or when you want people to be able to access your website, for example, you need to accept traffic from anywhere, from outside of your environment. Now you can specify if your ingress type is HTTP or TCP, your transport, if it's HTTP 1 or HTTP 2 or just automatic. Allow insecure connections if you want. You have to specify the target port. So if I'm doing an ASP.NET application, the one from my PowerPoint, for example, had in the Docker file port 8080 defined as the one that is being opened in my container. So I need to make sure this is also 8080. By default, this is by the way, this is a breaking change in .NET 8. So in .NET 8, your default port within a container for ASP.NET web applications is 8080. In .NET 7 and before, it was the port 80. So this is a breaking change. This is something that I learned the hard way. I was like debugging just like Simon before, like, why is this not happening? I just upgraded to .NET 8, but this is the one. So by default, the port is 8080 for ASP.NET in container. Then session affinity basically means that when somebody connects to your container, to a web application within your container on this specific port, because your containers can be horizontally scaled with a load balancer sitting on top. If you want to link them to that specific session, because they have a session active with cookie, the load balancer will make sure that that specific session is kept and that person will always hit the same replica for your container so that it doesn't jump to another scaled version and it loses its session basically. So you can enable this or keep it disabled. I'm not going to create it now because it takes some time to do that. I'm just going to show you the example. So this is a container app that I created before based on this application. This is a Blazor web application in .NET 8, and I just created one single page or component called home, and this home page will just show you the current machine name. This is a Blazor server running on the server, so it can actually show.
Sorry,
Yes?
we got a question. Simon, do you want to ask Johnny a question?
Is it the question in the chat?
Yeah.
So our
How
container.
can we use reservation to save some money?
Excuse me?
How can we use reservation to save some money? No, this is from Simon.
Okay, what do you mean by reservation?
Simon, you're muted.
Sorry. So it was back a couple of minutes ago when you were looking at the pricing for the
Yes.
For the deployment. One of the things that you can do from a cost saving point of view is you could buy an app service plan to reserve the compute time on Azure, to just bring that that overall spend down, and you can do either a year commit or a 3-year commit for app service.
Yes, yeah. To be honest, I can't answer that question because I don't really know if you can use that in combination with container apps. So it's a good question, but unfortunately, I can't answer it.
That's fine, no worries.
So yeah, this little demo application just returns the machine name and also a version which I put in as an environment variable. So an environment variable that contains some kind of version and the machine name. So that's what this application does. So if I run this application, this is the public URL, and I wait. Okay, let's go back here. Nope, it's done. It will just do hello. This is the name of the machine that is running my container. And this is the v1 environment variable that I've configured for this application. Now, how does this work? Your container app runs. I've specified where the container comes from. So it comes from my Azure Container Registry. And with scale and replicas, you can actually define how my container app is scaled. So you can see that there's a minimum and a maximum amount of replicas, so 0 to 10. So this is using the consumption-based profile, which means that I'm quite limited in how I configure my CPU and memory. But when I'm scaling down to 0, I'm not paying anything. And this is why actually it was taking some time for this page to load, because it was scaled down to 0 automatically. And I can scale up to 10 replicas for this specific container app. So this application, this Blazor application, can scale up to 10 replicas. So if I have a lot of users using my application at the same time, there's an automatic load balancer on top that will actually forward you to different replicas. So I can't really show you this right now, because now there's probably only going to be one replica. So if I refresh this page multiple times, you can see that it always hits the same machine because there's only one replica necessary. And by default, it's defined by the scale rules. And now it's the HTTP scaler. So this is using Keda, which is an open source tool for scaling in Kubernetes. But Microsoft implemented this in container apps automatically, so you can use that. You don't have to configure it. But you can, of course, choose different options. So this HTTP scaler will, depending on how many HTTP requests come in, will actually scale your application looking at those minimum and maximum replicas. Again, so it was 0 before, but because I hit it one time, it becomes 1, and it will be 1 unless I have thousands of requests coming in at the same time. If you want to change that, you can edit and redeploy a new version of your container apps based on the same image, same container image. So here I'm defining my container image. If I click it, I can actually configure the CPU and memory. And I can add some environment variables if I want. This is the v1 environment variable, which I've set before. But you can also change the scaling. So I can go from 0 to 10 or from 6 to 17 or something like that. And I can add some custom scaling rules. There's other scaling rules available, not only HTTP, but different scaling rules also. For example, based on messages on a queue, something like that, and so on. So very, very interesting here. Now I'm going to show you another example where I've actually did some hard-coded scaling. So if I go to scale and replicas for this second container app, I've actually put it to 2 minimum and 2 maximum. So I always have 2 replicas. So if I go to this URL, you can now see that I'm on a different machine than this one. This is my second container app. And if I refresh this page, you will see that the name of the machine is flipping between 2 machine names, because I have 2. This one is P9GMK, and this one is GJRVN. So it's 2 different replicas, so 2 different containers running the same application. And I have a load balancer on top. And the load balancer is just random. The load balancer will just randomize where my request will travel to, and because it's randomized, it will have like a 50-50 spread around those two instances. If I have 10 instances, it will be 10% for each if you do it long enough. So this is very cool, and again, very easy to do. I'm showing you all of this using the portal to make it very visual, but you can also use this from CLI. You can use this from your infrastructure as code, like ARM templates or Bicep. You can configure and set all of this, of course, using those things. Another thing that I want to show you is actually the third example. Is next to scale and replicas, you also have the concept of revisions. So each time, and maybe I need to go back first to the second one. So each time you create a new deployment, or let's call it revision, because that's what they call it here. So if you do scale and replicas, for example, you edit, you change these values, you change the scaling, you change the environment variables, doesn't matter, and you create, you're creating a new deployment, you're creating a new revision. Now, Azure Container Apps will keep all of your revisions for a very long time. So you have your active revision, which is your latest one. And then if you go to inactive revisions, you can see the previous one. So you can actually activate previous revisions if you made a mistake. If you did some wrong configuration in scaling, or you did some wrong configuration in your environment variables, or maybe you selected a newer version of your container image, then you can reactivate an older one to actually make sure that everything works again in your production environment, for example. So you can go back to whichever revision you have activated in the past. But to make it more interesting, you can actually change your revision mode from single revision mode to multiple revision mode. I'm not going to wait for this because I already did it in this example. And because I can have multiple revisions at the same time, you can actually create a new deployment via scale and replicas, or via your continuous integration, continuous deployment pipelines. And you can change your traffic to, for example, do A/B testing. You can, by the way, see that this one is scaled to 0. But 80% of my traffic will go to the oldest revision, and 20% of my traffic will go to my newest revision. So if you're creating like a new version of your application, but you're not sure that everything's going to work perfectly fine, you can just lower the amount of traffic and then just look at your logs. And if you see something wrong in your logs, you can quickly put this to 0, fix something in your application, and then put it again to 20 or 10 to see if everything works fine. And if everything works fine, you can change these values over time. You can go to 30-70, 40-60, 50-50, and everything keeps on working fine. You can basically disable the older revision and have your newest revision on 100%, because now you're sure that your new version of your application is stable. And I can also show you this if I go to my application URL. And if I go ahead and refresh this multiple times, I'm also having two replicas. My application is running twice. It's 2 revisions actually. So 2 different machine names. But if I keep on refreshing, only in 20% of the time I will hit one, and in 80% of the time I will hit the other one. And this is what you probably see now. So we have the CZ4J4. We have that one quite often, and then once in a while you see the other one popping up, 27, and so on. So that's a very cool concept here. Now, this was what I wanted to show you from Azure Container Apps. So you have a lot of flexibility in creating these orchestrated container apps. But you don't have all that complexity from Kubernetes. And I want to show you one more example of something that I'm actually using. So this is my personal Azure environment, so not my professional one. Unfortunately, as a consultant, I can't show you the ones that I'm using professionally, because I'm using them for my customers. But this one is one that I'm using myself. C# Wars is a game that I've created to teach students how to program in C#. So they need to write C# code in order to make a virtual robot do something on a virtual arena. It's a deathmatch game. I'm not going to dive into it quite deeply, but if you look at my GitHub repositories. There is the C# wars repo just there. And I'm using something called Orleans, which is an actor-based application model to create distributed applications. And I'm actually using 4 different container apps in one container environment. There's a web API, there's a web application, and then there's my Orleans host applications. They actually host my actors in my actor system, and they are scaled dynamically. And these 4 applications are working together. And there's actually a dashboard for Orleans that will show you all of your current in Orleans, it's called silos within your cluster. So I have multiple silos within my cluster. And in total, I have 8. So these are 8 host applications currently running. That is the vhost and the normal hosted applications. There's 1, 2, 3 vhosts, and there's 1, 2, 3, 4, 5 normal host applications, in total 8, and they are now all working together within that single Orleans cluster. And if you really look at the container apps itself, the host application is right here. If you go to scale and replicas, you can see that it's scaled to 5, so 5 instances, and that's exactly what we see here. We see 5 host applications. If I go back and I go to the vhost, which is validation host, and I go to scale and replicas, you can see that I have 3 of those. In total, they make up 8. So this is an example of something that I'm really using in let's call it production, and they work nicely together, perfectly fine. Very cool technology. Before I exit, or before I stop talking, just one very quick thing that I want to show you. There's a different kind of container app also. There's also a container app job. Interesting, it's just quite new. So you have container apps, but you also have container app jobs, which is the same concept. It's also a container that runs as part of a container environment. But if you create a job, it's not continuously running. It's more like a function app. You put some code into a container, can be a .NET console application that does something, and when it's finished, it's finished. And you can specify if you want to trigger your job manually. So you can use Azure CLI, for example, to trigger it, and then it will do something, and then it will stop when it's finished. So you only pay for when it starts, for how long it runs, and when it stops, you're not paying for it anymore. But you can also do it scheduled based on a cron expression. So you can schedule it like do something every day, do something every hour, whatever. Or you can make it event driven. You can do like do something when a message from a queue comes in, do something when something else happens. So this is the same concept, and you can combine container apps and container app jobs within the same container environment and have like your distributed application containing some jobs and also some long-running services or some web services all together in the same environment, which I think is quite powerful. And you will basically be able to run most of your application just as containers within container apps. And that's it. I think our time is running out, so I will shut up now. Again, if you have any questions, I will have a look in the chat in just a moment, and you can find the things that I've shown you on my GitHub and many other things also. So have some fun with that. Let's see. Do we have some questions?
Thanks, Johnny. That was really good. There's one question. I'm not sure if you answered it or not. I'll read it out just in case. Actually, there you go. It's up on screen. Are container apps in a container apps environment similar to deployments in a Kubernetes cluster?
So yeah, the deployments in a Kubernetes cluster are indeed, in a deployment, you specify a container or multiple containers and then a number of replicas. I think so. A container app is very similar to that. Yes. So a container app, so one container app within your environment is basically a deployment based on a container or multiple containers running on the same pod, and then you have a number of replicas, like how many times, how many instances of this container app do I want to scale horizontally. So in that way, I think yes, it's quite similar to that deployment. Of course, on top of your Kubernetes deployments, you also have these services, I think they are called, to make sure that you're able to connect to them from within your cluster or even outside of your cluster if you put some ingress on top. So the concepts and the ideas are very similar indeed, but they're much easier to configure. I hope that answered your question.
Hopefully it did. Sullivan, if you're still online, feel free to post your any further questions. But I think it sounded like a fairly detailed explanation, Johnny. So thanks very much for that. Any of the online speakers have any questions for Johnny?
Nope. It's brilliant, Johnny. You explained quite a lot.
Yeah, I know. When I start talking, I always go.
Yeah, it was amazing.
No
I've got a question, Johnny. So, have you used Container Apps in projects before at work? And is it, because I know it's still like evolving because there's still some updates on it, still maturing.
Yes, it's quite new. I think it's a couple of years old now. I think 2 years old or something. It's been in preview for almost a year, and now it's out of preview for some time already. But you can see, like, every couple of months there's some new things added to it. So it's very much still in it's evolving quite rapidly. So yeah, so I've been using it for a couple of my projects. Yes, smaller projects, not like thousands of microservices.
So you wouldn't think it's like production ready yet because it's still evolving?
No, I think it is production ready. It's actually a good thing that it's still evolving. So it is production ready for sure. I would certainly say that. And the fact that it's still evolving is its new features are still being added to make it even better in use. For example, the first version of my C# Wars game that I did, just going to show you very quickly. So Simon showed you the same thing for static web apps, but if you open a web application in a container app and you've configured ingress, then you also have custom domains, and in custom domains, by default, your Azure web app, your Azure Container App has this very weird URL, like your name of your web app. Then you have some random, in this case, wonderful mushroom dash whatever number, and it keeps on going. So you of course want to have your custom domains. You add your custom domain. You select your domain like c#wars.com, and then, just like, again, Simon showed you, you need to add those records to your DNS, your domain DNS data, and then you can actually, it will create the certificates for you automatically based on just encrypt. This is one of the features that is quite new. It came out a couple of months ago. Before that, you needed to do this manually, so you needed to create like a function app that did the just encrypt stuff for you every once in a while to refresh your certificate. So these things are added over time to make it even more user friendly for developers, which I like. So again, a long answer to your question.
Okay, brilliant. So we've got, let me see, one more question. Okay, so I got someone saying thanks. Session was so insightful.
Thank you. I'm very happy.
Yep, I think that's all the questions. I think well explained, Johnny. Thanks so much.
No worries. Let me play a mini clip for next episode, and then we can.